नहीं देखो, what we are nowhere saying कि we are covering all the possible scenarios. If you want to do things where things are not rational, right, you will need to formalize other things too that we are not doing in this course. That's it. So if your agent is not rational, we are not covering any such instance in our course.
अगर वो ग्रेड एग्जांपल लेते हैं,
हाँ,
ग्रेड में एक ग्रेड है,
हाँ,
राइट, एंड और उसका कोई पॉइंट नहीं है, बट एंड गोल तक जाने के लिए रैबिट से अगर बी से रन ओवर द रैबिट क्विकर वी कैन रीच द एंड गोल क्विकर.
okay,
बट देयर इज आल्सो लॉन्गर वे जिस पे वी डोंट रन ओवर द रैबिट. बट अगर हमारा एजेंट है, तो एजेंट को रन ओवर द रैबिट एज गोल बिकॉज़ इट हैज टू मैक्सिमाइज इट.
नहीं देखो, यू कैन ऑलवेज कंस्ट्रक्ट सिनेरियोज जिसमें अपन जो कर रहे हैं वो काम का नहीं है. What we are saying is we are more bothered about scenarios that we are talking about. So that's it. I mean, when we say we will consider only those situations where our agent is rational, that's what we are saying. We are saying कि हमारी boundary ये है. Of course, that boundary does not imply कि you cannot go in real life outside that boundary. So you can add a hell lot of other things too, but we are in this formalism, we are talking about just this part. We are not saying that at all. What we are just saying here is our presumption is agent is going to take a rational decision. अब आप उसमें इमोशनल ले आओ और कोई चीजें भी ले आओ, यू कैन ऑलवेज कीप ऑन मेकिंग योर सिस्टम मोर एंड मोर कॉम्प्लेक्स. ऑल राइट, सो वी स्टार्ट. So we start with MDPs. We have seen MDPs before, and अब तो एग्जाम देने के बाद में you probably right. So the same problem as we had before. Laptop lids down, no noise now. Right? Chalo. So same problem that we had before, I am not going to repeat it. Agent received rewards, whatever. Okay. Markov decision process we have talked about. There are states as action A, transitions, rewards and start state, and we have also talked about policy, utility, values and Q values. What are values? What are values? So what are values? See again we said how can we summarize this course जो अपन एकदम शुरू में किया था, maximize the expected utility, right? So what are those values? Again ये वही utility है, right? Expected future utility from a state. So these are values and जब अपन उस पे optimal लगाते थे तो they are the optimal values. You can't do anything better than those values. So you can't receive values better than optimal values if you put star the way we have been defining it. What is Q value? Expected future utility, exact same thing but from a Q state and not from a normal state. Okay, what is the difference between a Q state and a state? See, state is something that you actually have physically here, right? What was Q state? It was the chance node. Once you have taken your action, you have no control over what is going to happen next. Okay, so this was our Q state. The value of a state S, V star S, expected utility starting in S and acting optimally. We have talked about this before. The value of a Q state is expected utility starting out having taken action A from state S and thereafter acting optimally. Optimal policy, optimal action from state S. So what is a policy? जब आपको policy given होती तो what is it that is actually given to you? So this is important. We know how should I act in every state, and if that particular if we put this star here, then what is that policy? Optimal policy. So done. This tree I hope is fine. So these are values. Okay. All right. Next. How did we get these values, by the way? It does not matter what is the exact number. What matters is how did we get. So we got this using Bellman equations. And what are these values? How are V star and Q star related? So maximum of that Q state will be your V star. How to be optimal? What is this particular equation? So this is Bellman equation. Take correct first action. This particular statement belongs to which equation? Take correct first action. So what was this? Take and keep being optimal from there on. Right? So but I think you understand this. This is also we have done before. So Bellman's equations, definitions of optimal utility via expected max recurrence gives a simple one-step look-ahead relationship amongst the optimal utility values. So this again we have done so many times before. These are the Bellman equations and they characterize optimal values in a way we'll use over and over. Okay. So basically this was your last question in midterm. Last से पहले वाला just, right? Just this slide was there. That's it. Okay. And our last class was on value iteration. What is value iteration? देखो ये सारा confusions they will be there now. All are manifestations of Bellman equations. Okay. So Bellman equations characterize the optimal values. This is how you write them. You are writing V star in terms of V star of some successor state. Value iteration computes them. So here you are just characterizing, here you are computing, because you are just giving me ki Vk plus 1 will be computed in terms of Vk. So exact same thing, that's it. Value iteration is just a fixed point solution method. Through VK vectors are also, so okay. So value iteration is just that we have written these Bellman equations in this form. Convergence. What will be convergence in this case? What do we mean by convergence as such? Right. So what does it mean? Change becomes. So what does that give me? नहीं, see when you talk about a series, जो कि आपने मैथ वाले कोर्सेज में किया होगा, what does it mean to say कि series converges and a series diverges? So even if it's an infinite series, if it converges, what does it mean? Values will take a particular, so basically this series will take a particular number, okay, and if it diverges, right. So what does this mean? Convergence means it will give you one particular value, you sum it over everything and एक number आएगा. What about divergent? कुछ भी नहीं, कुछ भी वैल्यू आते ही तो that is convergent. Divergent means goes to infinity. Okay, so that's what it is. Here by convergence, what do we mean? So in that series, what do you have? If you have 1 plus next term plus next term plus next term and so on, when do you say this series will converge? When the further things that you are adding to it, they become diminishingly low, right? So जब आप next term add करोगे, that is close to 0. Next term जो add करोगे, that is even further closer to 0 and so on. So this whole thing will converge to one number. This is all we mean here, right? So convergence here means how do we know that VK vectors are going to converge? Because if they won't converge, what will happen? You won't have a number and you are looking for a number, okay? Else what will happen? This thing, here we are summing up to so many things, right? And potentially these are infinite trees. So अगर infinite terms को add करोगे, if they don't converge, you won't get a number, you might go to infinity, right? So here the argument is that the change that you are going here, that change is very small and this change actually further decreases. How do you ensure that? So if I tell you gamma is equal to 1, what will happen in this case? In that case, it may not converge. Okay, you cannot prove that it will converge. Okay, so look at this last line. So Vk and Vk plus 1 are at most gamma k max are different. Okay, and this keeps on decreasing as you go, as you increase k. So as k increases, the values converge. What do you mean by convergence? अपना एक लाइन में convergence का क्या मीनिंग है यहाँ पे? We want values and we want those values to be finite. So we are just saying कि आप ये जो इतना you are computing the value of a state in terms of a next state, you are doing it recursively. Just make sure that in the end I will get a number. Okay, in the end I don't want infinities there. Policy methods now. Policy evaluation. Okay. What were fixed policies? What are fixed policies? What does that mean?
It has to follow that without.
Right. So fixed policies basically mean same चीज जो अपन ने बात की थी. What are policies? कि for every state I know what action to take. So do the optimal action. Expecting max trees max over all actions to compute the optimal values. What does this line mean? I want to compute value here. कैसे compute करेंगे? I need values of all these Q states and then max over them. Whichever is the max over them, you just take that value here. Okay? What happens in this case now? देखो ये सारी की सारी चीजें आर बीइंग डिराइव्ड फ्रॉम बेलमैन इक्वेशंस. तो बहुत माइन्यूट सा डिफरेंस है, बट प्रैक्टिकली दैट गिव्स यू अ लॉट ऑफ डिफरेंट थिंग्स. विल दोज थिंग्स विल बिकम क्लियरर एज वी गो क्लोजर टुवर्ड्स द reinforcement learning. Now what does pi say? Here what we are looking, do the optimal action. Here we are saying in case of fixed policies, do what pi says to do. What is pi? Policy. So if you are in state S, pi S will only give you one action. So this is that action. Take action whatever pi says in state S. So you go to this particular Q state. From here do we change anything, or this is same as that one? This guy is still same as that one. Why so? Because policy is only giving you what? Policy is just telling you what action to take in particular state. It is not controlling environment in any way. So अभी भी it is the same thing. पहले वाले केस में क्या था? I had these options to take. I can go to forward, backward, right and left. अभी पॉलिसी की वजह से मेरे पास क्या हुआ है? जस्ट आई एम जस्ट टोल्ड कि whether I should go forward, backward, right or left. उसके बाद में क्या होगा? That is still same as whatever we had before. Okay. So expecting max trees max over all actions, this was done. If we fix some policy pi s, then the tree would be simpler. Only one action per state, though the tree's value would depend on which policy we fixed. Okay. What does this mean now? देखो अब इसमें जहां तक हो सके try to discuss more and more, because we are almost there. Next lecture या next to next lecture में we'll be there on reinforcement learning. So what does this mean? Though the tree's value would depend on which policy we fixed, because ये जो values थी ना भाई, earlier तो हम क्या कर रहे थे इसमें? We were computing the max. Okay. Now if let's say this was the max, but let's say this is not the max, so what will be the value here? Value here will be coming because of this particular action, but it's not the max. So though the tree's value would depend on which policy we have fixed, it can be max, it can be not max, it can be something and so on. Okay. Now another basic operation is to compute the utility of a state under a fixed, generally non-optimal policy. So why do we want to compute the utility of a state S under a fixed and it says generally non-optimal policy? See, compute the utility of a state S under a fixed which is generally non-optimal policy. Why so? Because if you know that this is optimal policy, there is nothing left to be computed. So define the utility of a state S under a fixed policy pi V star S expected total discounted reward starting in S following. So how will we write this particular equation now? Next equation क्या होगी? बेलमैन इक्वेशन से आएगी. Okay. We are looking for V pi S. So let me give you this equation. Recursive relation, one step look ahead, Bellman equation again. So how are we getting this particular equation? How is it different from the Bellman one? Max हट गया, why max हट गया? Right, because earlier you had max over this, that I want to, so यहाँ पे V star S was here, and now we are saying I am not looking for optimal value, I am looking for values under this particular policy, values under this particular policy. So you have so you don't have max here. So recursive relation, no max here. इससे क्या चेंज हुआ? Sorry? Okay, time complexity will be less. Why? Right. So अब you are not computing all these guys. That is one thing. What more? V fix हो गया. Equation becomes linear. So why equation becomes? What is a linear function, by the way? If I ask you, is this linear? Right? So this is not linear. Is this linear? Yes. So this is equation of a line, but is this linear? No, it is not. How do you prove whether something is linear or not? How do you know whether something is linear or not? Power of x. Okay. So you have then things are linear. Okay. Now tell me, does this hold in this case? क्या दिक्कत हो जाएगी इसमें? You will have b coming twice. इस साइड में b will come twice, इस साइड में b will come just once. So this is not strictly linear. What is this? This is affine. So these are affine functions, and machine learning में, deep learning में आप जो कर रहे होते हो, they are not linear functions, but they are affine. You will see this word affine a lot of times. अपन इसको by abuse of notation बोल देते हैं कि this is linear, but actually not linear. This is affine. So in deep learning, when we say कि we are computing linear computations, we are actually computing affine. So now, हाँ, इसको, हाँ, हाँ, right, हाँ. नहीं, नाम चेंज है. आप रिसर्च पेपर्स पढ़ेंगे, यू विल फाइंड ओनली अफाइन. ओके, बट normal lectures में anywhere you will see we call it linear. But everybody who does this, they will first tell you that it is affine, but from now on, if I say affine, if I say linear, I mean affine. Okay, because these are biases, these are your normal weights and so on. Okay. So if you see this one should hold, if this holds, then that particular function is linear, else it is not. If you see max sitting here, it won't follow this. If it is not there, it will. Okay. So this particular equation becomes linear. How does this help me? How does this help me?
We can cover deeper topics. Same complexity में ज़्यादा deep कर सकते हैं.
Same complexity?
में ज़्यादा deep explore कर सकते हैं.
But is that the only thing that linearity gives you?
Constant
Okay, we'll come. So V prime S max चला गया आपका, and now what you have is this one. If this were earlier, आप इसको कैसे लिखोगे? There were two equations, V prime in terms of max of Q star SA, then Q star SA will be this thing. अभी आपके एक ही इक्वेशन में दोनों चीजें हो गई हैं. Done, because there is no max of Q star SA. Now we talk about policy evaluation. ये देखो, ये नाम बहुत ढंग से देख लो. रीइंफोर्समेंट लर्निंग में ये नाम बहुत एक स्टैंडर्ड चीज के लिए यूज होते हैं, बट they are usually very confusing, like deep learning terminology. There are two policies here. What is the first policy saying? Always go right. Okay, and this particular policy is saying always go forward. So this is always go right, this is always go forward. What do we plan to do here when we say policy evaluation?
Which policy is better? We run multiple policies and choose the one which gets the best score.
Sorry?
We run multiple policies and then choose the one which gives us the best.
Right. So you are looking for the best policies, better policies. Always go right is better or always go forward is better? And how do I know that? Because of these values. Again, like before, I will say what exactly these values are. They are not really of that much importance to us. What is important is I am able to compare that same thing, okay, for these two policies. Always go right, always go forward. Can you explain the relativity between these numbers? So for example, here I have something positive and not negative. What might explain this? Noise will explain this. How come? Because there are still some chances that I take this action, but I may slip into this one. Okay. What happens in this case? So like all of you said, this particular policy is better, but here the comparisons were trivial. Policy evaluation. So let me just talk about policy evaluation today. So how do we calculate V star S for a fixed policy pi? How do we calculate V's for a fixed policy pi? Turn recursive Bellman equations into updates, value like iteration. V0 pi S is 0 and V pi k plus 1 S is this. So हमेशा पहले हमारे पास वैल्यू इटरेशन में वी हैड, सॉरी, वैल्यू इटरेशन वाज लाइक व्हाट? V of k plus 1, right, and V star S was given as right. How is this different from value iteration? There is no max. Okay, and you are writing, why is this guy 0? So deep down in the true, discounted values are 0. What about this guy? You are writing this in terms of this, that's it. Same as Bellman equation, now no maxes. Efficiency is order S square per iteration. Earlier it was S square A, and now it is just S square. Without the maxes, the Bellman equations are just a linear equations, so you can solve it with whatever. Policy extraction now. So which one do you prefer? Policy evaluation or value iteration? I mean, so we'll do something like policy iteration later, so let us leave it here. Policy extraction. What is policy extraction? So let's imagine we have optimal values V star S. And how should we act? How do I decide how should we act?
Follow that policy.
क्या चीज?
Follow that policy.
No. So we are trying to compute the action from values. देखो, all this is super confusing, at least for me. Okay? आपने कुछ टर्मिनोलॉजी चेंज की and things change a bit. So what are you exactly trying to do? Compute actions from values. पिछले वाले में क्या था? देखो, all our Bellman equations we are just trying to see which version we are talking about. पिछले वाले में इसमें क्या था? So what are we computing exactly? We are computing values given a policy, right? So given an action basically in everything. So we are computing values. That was policy evaluation. अब इसमें देखो गड़बड़ें जो मेन करके आओगे, what is policy evaluation, what is policy extraction, right? So policy evaluation में क्या कर रहे हो आप? पॉलिसी को evaluate कर रहे हो. Evaluate means given two policies, I try to compare them, which one is better, let's say. Policy extraction, extraction का क्या मतलब होता है? You want to extract policies. So if you want to extract policies, certainly what is not given to you? Policies. So something will be given. What that something will be given? Values. Values are given to you, but policies are not known. But given these values, can I say there will correspond a policy to it? Okay? So there will correspond at least one policy to it. So these are the numbers given to me. जब अपन एकदम शुरुआत की थी, right? So what were we interested in? What did we want to compute? You want to act rationally. You want to see what we are more interested in are these numbers, or what action should I take from a particular state? We are more interested in what action should I take from particular these states, right? These numbers, they are constructs from something, right? Those numbers का काम क्या है? Numbers का काम finally आपको ये बताना है कि given in particular state what should I do? What action should I take? Okay? So these numbers are there just to do that. Now अभी अपने को इस current scenario में क्या given है? In current scenario में अपने को ये values given है. And we want to extract policy from that. Okay? Extract policy means I don't know what set of action should I take here. Give me the actions. So how should we act? Given these numbers, how should we act? It's not obvious. Why it's not obvious? Why it's not obvious? नहीं, पॉलिसी नहीं है, but how would you compute? So can you help me compute given these values? And how do I know that? So for example, if I am here, you say इसकी वैल्यू ज्यादा है तो इधर चले जाओ, right? So look at my neighboring states, जिसकी वैल्यू ज्यादा है, I go that side. Okay? What else? देखो, आपको जब से अपन ने MDP शुरू किया है, इनफैक्ट जब से अपन ने बेलमैन इक्वेशन शुरू की है, every answer lies in Bellman equations. So tell me what is happening in this year now. Only one change. जितने भी अपन डिफरेंट नाम पढ़ेंगे, सब में एक वर्ड हट जाएगा, ऐड हो जाएगा, चेंज हो जाएगा, एंड दैट्स इट. अदरवाइज इक्वेशंस विल रिमेन एग्जैक्टली द सेम. इसमें क्या चेंज हुआ है? Earlier it was max, now it is argmax. Why? What is argmax? So give me that particular A for which this quantity is max. Exactly the same thing जो आप पहले कर रहे थे, right? So pi star s, लेकिन अभी इसमें मेरे पास कौन सी वैल्यूज हैं? I know these guys. Okay, most likely I know these guys too. So given all this, I am supposed to compute कि कौन सा A is maximizing this value. Okay? एक सेकेंड, हाँ. This is called policy extraction since it gets the policy implied by values.
सर इसमें नॉइज भी गिवन होगा अगर
So you would like to know what are these guys? Of course. एंड ये सारी चीजें लिखते रहो बिकॉज जब आपके रीइंफोर्समेंट लर्निंग आएगी इक्वेशंस विल स्टिल स्टे द सेम इक्वेशंस. द ओनली डिफरेंस इज ये आपको नहीं गिवन होगा, ये आपको नहीं गिवन होगा. सो वहां पे अगेन वी विल मेक डिफरेंट नेम्स, डिफरेंट ट्रीज, डिफरेंट मॉडल्स, मॉडल फ्री, मॉडल विद मॉडल एंड सो ऑन. बट उसमें आपको T नहीं गिवन होगा, R नहीं गिवन होगा. So you will have to run experiments to figure out what is T and what is R. तो अपने ग्रिड वर्ड में कैसे डिफरेंस होगा वो? ओके, सो अपने ग्रिड वर्ल्ड में कैसे डिफरेंस होगा वो? इन टर्म्स ऑफ रीइंफोर्समेंट लर्निंग, 2 मिनट के लिए. T is not given to you, R is not given to you. So basically you don't know कि यहां पे फायर पिट है और जिसकी जो भी रिवॉर्ड है. ओके, सो हर एक एक्शन लेने से पहले आपको नहीं पता कि what this action is going to give me back. So एक बार आपने एक्शन लिया, you went this side, you got reward -10 and then now you know कि यहां पे फायर पिट है. ओके,
सर बट आर तो लिविंग रिवॉर्ड है.
सॉरी,
आर तो लिविंग रिवॉर्ड है.
even that is not known. All right, so batteries are over it seems. Right, so नहीं, right, we were here. So this is called policy extraction since it gets the policy implied by the values. So earlier you were given actions, policies, compute values. Now given values, compute policy. Okay, and that is called policy extraction. पिछले वाला था was policy evaluation. Okay. Why argmax? See, argmax क्या होता है? Right. So give me the value of A that maximizes. So इस केस में let's say it is north. Okay. So computing actions from Q values. भाई एक बार ये stop हो जाए then let me know. हाँ. So computing actions from Q values. Let's imagine we have optimal Q values. ये बात अपन पहले कर चुके हैं. We once if we are given optimal Q values, how should we act? देखो again see the contrast here. If you are given V values, क्या करना पड़ेगा आपको? If you are given V values, आपको ये इक्वेशन से निकालना